Hello and welcome. In this video, we are going to take another look at Matlab numeric vectors, or another way of thinking of them is one-dimensional arrays. This time, we are going to focus on how to build them using Matlab functions. Now, this video assumes that you've watched some of the earlier videos, possibly the one that focuses on how to create Matlab vectors manually, as well as using the colon operator. But again, in this particular video, we are going to leverage some of the functions in Matlab that can be used then to create a vector of doubles. Now, the first thing to note here is this is not supposed to be a comprehensive view of all of the functions in Matlab that can create numeric vectors. Instead, what we're going to do is we're going to put a little twist on it where I'm going to look at patterns in the documentation that allow for you to better understand how the Matlab documentation can be used to see or to understand how a given function works. And so let's go ahead and get started here. I've got about half a dozen functions in Matlab that I'd like for us to play around with. And there, as I said earlier, going to be plenty more, but hopefully after this video is done, you can get an appreciation for the patterns. So let's go ahead and get started with an easy one, and that is going to be the ones function. And the ones function, I'm going to go ahead and pull up the help here so we can work along with it. It does kind of what it sounds like it should do. In other words, it simply creates a vector one-dimensional array, or even a multi-dimensional array, which we'll cover later, of ones. And if you recall from our earlier videos that the default numeric data type for a numeric value will be double. And so what the ones function does is it simply creates a vector of the size that you specify of the value 1 and of the data type double. And you can notice here, based on the help, that we have a number of different overloads or number of different possibilities. And what we're going to do is we're going to focus on this third one here. And specifically what we want to do is we want to look at this SZ1, comma, SZN. Now, again, that's kind of a bizarre syntax, but what this does is this allows for us to specify the dimension or the length of each dimension for an array. Now, we're going to start off with vectors, and those are going to be the examples that we use in this particular video, but then we're going to move on to multi-dimensional arrays. So again, what we're going to do is we're going to pick some poor variable names here. I'm just going to start off with the letter A. We're going to call the ones function. I'm simply going to specify that I want to have a 1 by 10. And again, those values are kind of arbitrary. It just fits nicely in the command window. And I'm again going to leave off the semicolon. And what this will do is this will create a 1 row by 10 column vector of ones, and they will be type double. And again, to see what I'm talking about here, let's just go ahead and highlight this. And we can either right-click and run or evaluate the selection, or simply hit F9. And you can see that down here in the command window that I do, in fact, just simply have a vector of ones. And you can also click on the variable in workspace. I'm going to go ahead and move the help window. We will be using it quite a bit in this video, just so you could see here then what we have in mind. And you can see here that, in fact, I have 10 ones, just as expected. All right, so let's move forward here with some other examples. We're going to go ahead and show that we can also create a column vector. The first one was a row vector, and I think you can probably guess that I can do so by just simply swapping the indexes or swapping the values for each dimension. In this case, then, as you would expect, this creates a column vector or a 10 by 1 vector, again, of ones, nothing changes there, and of type double. Now, at this point, you could probably guess the pattern that we're going to be repeating here in the remaining functions, in that I'm going to be looking for this SZ1, comma, SZN. And again, in later videos, we'll see that we could specify multiple dimensions. We're going to focus just on our vectors here. And so the next one that we want to take a look at is going to be the zeros function. And I guess you could argue that we could have probably looked at these in any order, but more importantly, what we're interested in is seeing the pattern. And again, you can see here that we have the ability to use this overload that allows for us to specify the dimensions in any number of dimensions. So in other words, the length or the size of each of the dimensions. And again, to do this, we will just simply create the vector using, in this case, the zeros function, and then we have a 1 by 10, and then also we can do the same thing for a column vector. Now, keep in mind, I didn't mention this in this video yet, but I've mentioned it in earlier videos. We can, of course, always transpose an existing vector and accomplish the exact same thing. This just sort of eliminates an additional step, and you can see here that if I were to run these three right here, that I now have a C vector, which we can either check in the workspace or down here in the command window. And it's a 1 by 10 vector of zeros. My D vector is a 10 by 1 column vector. And since I use the transpose to be able to create the E vector should also be a 10 by 1. And again, I'm not going to do the comments on every single one of these, but at least for these first few, let's go ahead and take a second to document then the dimensionality here. So we have a 1 by 10, a 10 by 1, and then also, since this is a transpose of C, then this is going to be a 10 by 1. Moving forward with a couple of other functions that we want to look at, you'll see that there is a true function that corresponds to the logical data type in Matlab, but the part that we're interested in is going to be, again, this pattern, this SZ1 to SZN pattern. And again, it's the exact same as with the ones and the zeros. So in other words, if you need to create a vector of logicals, well, you simply use the true function and you specify then that you want a 1 by 10 or a 10 by 1, or whatever size that you're interested in. Now, I think you can guess at this point the pattern. We'll see the same thing in the false function. And in this case, let's just mix it up just a little bit so you can see that we can create then a column vector of falses. Now, you'll notice that in the command window that MATLAB represents the true and falses as zeros and ones, or specifically the trues are 1 and the falses are 0. Sorry, I got those backwards. But the data type is in fact different. So you want to be careful about that. In other words, MATLAB will let you do things like setting true or comparing true to the number 1, and that will of course return true because MATLAB recognizes true as 1 and false as 0. Just want to be aware of that and be careful about that, that technically speaking, they are different data types. Now, moving on with this, let's take a look at another little interesting set of functions. This is going to be in the form of our random number values. And so we'll start off with the rand. We'll also look at the rand n, not m, and rand n, and then lastly the rand I. And again, these are not the only functions that produce vectors, but these are just going to be some of the common ones that you're going to use initially. And so we'll start off with our rand function. And again, remember the point of this video isn't to go through all of the possible vector functions, however, more to look at the patterns in the documentation so you can appreciate quickly, along with the description of the function, how to use the function. And again, you'll see there's that SZ1 to SZN pattern. And again, you can see that you can just simply create a vector, either a row vector or a column vector, and then later on multidimensional arrays using the pattern of specifying the length of each of the dimensions. And so what we'll do here is we'll start off, let's go ahead and use our H here. Our H then is going to simply be equal to the rand of 1 by 10. And we're going to go ahead and see here that we can get then a random set of values. We're going to come back to this in just a second, and I'll actually talk about it a little more in a later video. However, we want to sort of appreciate what the difference between these functions are as well. You'll notice that it is a uniformly distributed random number. And specifically, what is not mentioned directly in this description is that it returns values from 0 to 1. Okay, so this could be very useful, particularly when you are creating test data. In other words, basically, you can use the random function to just generate some values, and then you can scale them or shift them appropriately. And again, we're going to cover that in a later video about how and why you would go about doing this. But let's now take a look at the rand_n function. And the rand_n function, if you pull up the help, that you'll see here that it also too has this pattern of sz1 to szn. And the difference between these two then is essentially the range of values over which it acts. Now, I'm going to skip I for just a second. Instead, I'm going to focus on our J variable. Again, I just don't want to conflict with I just as out of habit, because I is, of course, the imaginary number. And then we can look now at our rand_n. And again, I'm going to create our row vector. In all of these examples, we could do these as column vectors as well. But there's a reason that I want to do it this way real quick. And you'll notice that then we have both positive and negative values. And the key here is that these follow a normally distributed random numbers or a normalized distribution. And again, if you're familiar with some basic statistics, which we won't really cover in this video, you can appreciate that then these values are going to be centered around 0 and can technically extend both in the negative and positive direction. Now, again, you can see here that we have sort of a nice little mix here. We have 1, 2, 3, 4, 5 positive values and 5 negative values. Again, you're not necessarily guaranteed of that, but statistically speaking, that seems logical. And then what we can do is we can also look at our last random function, and that's going to be our rand_i. Now, our rand_i behaves just a little bit differently in that it does have the same overload right here of the sz1 to szn. However, it includes an additional input argument, and that is of the I max. It turns out it's actually got a couple of overloads that we might be interested in, but we're going to focus on this first one right here, where we have to specify the I max followed by, again, the same pattern of the sz1 to szn. Now, to understand how this works, let's again look back here at the help. Specifically, we want to understand what is I max, and that is simply the largest integer in the sample interval. And you'll notice that how this works is it actually starts off at the value of 1, not at 0. And again, there are some games that we can play with this. For this brief introduction here, I just want to show you how you would go about creating then the same length vector as we have been creating earlier. In other words, that 1 by 10, but this time I'm going to use the rand_i. I'm going to specify values up to a maximum of 100, but I simply want, again, a 1 by 10 vector. And so if we run this one right here, you'll see that I have random integers from 1 to 100. We can't see that necessarily. It depends on which ones you get, but I don't have, for instance, a 1 or 100. You just have to assume that we technically, if we ran this over and over again, that we would probably eventually see a 1 or a 100. But most importantly is that even though these are integers, or that we are specifying that we want integers, the data type for K, if you come over here, is in fact still double. And so of all of these functions, all of these, with the exception of the true and false, produce the default numeric data type of double. Now, again, we can play around with all sorts of combinations. We can look at column vectors. We can later on look at multidimensional arrays. That isn't really the purpose for this particular video. We'll also take a look at how to use the rand functions in depth later. More importantly, what you should get out of this is the idea of this pattern in the documentation. And again, to reiterate, if we go back now to the rand function, we'll go back a couple in our help browser. And you can see here this pattern of this sz1 to szn. And this just simply allows for you to create these one-dimensional either row or column vectors. So hopefully you found this video useful. As always, if you have any questions, comments, or concerns, don't hesitate to reach out to me. And thank you for watching.